Okay, so welcome to section 5.4, the normal distribution. Normal distribution. Okay, so definition. Okay, so a normal distribution, that's what we're defining. A normal distribution of a data set. A data set has a bell shape. Say bell. Or do not. I think is bell shaped sounds better. So is bell shaped. Is bell shaped. And has a standard deviation. A standard deviation. Deviation of 1. Okay, so it's going to look something like, let's see if I can draw it. Something like so. So this is our bell-shaped curve, normal curve. And so basically the average would be right in the middle, the mean. So this would be the mean right in the center. And then we would have standard deviations. So 1. So this would be a -1 and a +1 from the average or the mean. And then a -2 or +2 from the mean. That's 2 standard deviations. And then down here would be -3 and +3. That's, too far away, aren't I? Let's see. So this is only 2. Okay, so -3 and +3 standard deviations away from the mean. And of course I reused a color. So let me actually no. I will change +3 and -3 to pink. Okay, so that means I need to change these lines to pink. Okay, so what's interesting about this is that, what color should I use? Let's use hot pink. Okay, so between ±1 standard deviation, we have 68.2% of the data. So 68.2% of the data is within 1 standard deviation of the mean. Okay. However, if we go out to 2 standard deviations from the mean, that's going to be 95.4%. So 95.4% of the data lies within 2 standard deviations of the mean. And if we go out 3 standard deviations, actually maybe I could not skip a line. So if we go out 3 standard deviations, that's 99.7%. So 99.7% of the data is within 3 standard deviations of the mean. So anything outside of that is going to be an outlier. Okay, so hopefully that makes sense. Maybe I should put some lines here to indicate what I mean, no pun intended. Okay. Okay, so hopefully that makes sense. Oh my goodness, these notifications. Maybe I should go offline while I'm doing this. Okay, so let's recall. And this recall is, pardon me, this recall is going to be, I'm going to post the definition sheet to this module. So recall the population, oh, having issues writing population. So is the entire group, entire group from which a sample set of data, so from which a sample set of data may be collected and to which the conclusions are applied. But, oh, maybe I should, yeah, I'll just state that aloud. So definition. So mu, this is a Greek letter. It looks kind of like an M, and it is. And I'll define it below. So mu is the population mean, so it's equal to the population mean. So x bar is the sample mean. Sample mean or average, right? And then sigma. Oh, my sigmas are not very good. So sigma, I'll define that again in a moment. So is the population. Standard deviation. And S is the sample. Standard deviation. Okay, so let's note down here. So mu in English is spelled mu, and it's Greek lowercase m. Lowercase m. And then sigma. So sigma is Greek lowercase s. So Greek lowercase s. Okay, so we're changing from English to Greek and that's going from sample to population. In fact, I don't really need to skip a line, do I? Yeah, that's okay. Okay, so definition. A a z-score. That's what we're defining. A z-score for a datum, a single data point, a datum x, in a population now. Population. So measures how many standard deviations. So measures how many standard deviations, 1, 2, or 3. So how many standard deviations or more standard deviations from the mean, it lies, x lies, and is given by the z-score is equal to the data point x minus the population average or mean mu divided by the population standard deviation sigma. Okay, so I'm just going to do a couple examples of this. Okay, so for example, so find the z-scores for the following. So find the z-scores for the following. Okay, so number 1, let's say I give you that mu, the population mean, is 6. I give you this sigma. Draw my sigma a bit better. Sigma, the population standard deviation, is 2. And let's say the data point is 3. Okay, so the z-score is just going to be the quotient, the difference between the data point x and the population average mu divided by the standard deviation for the population sigma. Okay, so what this gives us is 3 minus 6 all over 2. Okay, so 3 minus 6 is negative 3 all over 2, which is negative 1.5. Okay, well, let's see. Pardon me. Okay, so if I have a normal distribution, something like so, and my average, what is the population average or mean here? Well, I probably should have color-coded it. It's green. Population mean is 6. I know my population standard deviation is 2. So that means that this must be 4 because I'm 2 away. And this must be 8 because I'm 2 away. And I claim, so my data point is at 3, which is about here, right? Eek. Maybe about here. Why is that not doing that? So my data point is at about 3. Okay. Actually, I don't like that. I'm going to make it about here. Make my life easier. Okay, so 3. Okay, but my z-score states that I'm negative 3 over 2 or negative 1.5 standard deviations away from the mean. Well, yeah, if my standard deviation, if I went another 2, so each standard deviation is 2 units wide. If I go to the left 1.5 standard deviations, I do get to my data point, 3. Okay, let's do another one. Hopefully I won't cough as much. Okay, so let's say my population average is 4. Let's say my standard deviation is 1, which means now I'm on a normal distribution, right? Let's say my data point x is 5.75. Okay, so the z-score, I know I'm going to do the population, the data point minus the population mean. So this is going to be data point x, 5.75, minus the population mean, 4, all divided by the standard deviation, 1. 1. Okay. So what this gives us then is 5.75 minus 4. And thank goodness I'm dividing by 1. That's a number I'd like to divide by. So 5.75 minus 4 is 1.75. Okay, so what that means, let's look at another graph. Maybe I could put it here. So let's do our nice bell-shaped curve, something like so. So my average, my mean, right in the middle is 4. My standard deviation is 1. Let's make this 3, 2, 5. Oop. 6. Okay, but my data point is at 5.75, so that's about here. That's 5.75. Okay, well, how far or how many standard deviations? Well, thank goodness this is measured as 1. So that's 1.75 standard deviations away from the mean. Okay, hopefully that is making sense. Anyways, I will see you guys in the next video.